Now we come to the topic of projectile motion. And projectile motion is simply whenever we launch an object, and once it's launched, the only acceleration it's experiencing is the acceleration due to gravity. So this holds for objects that are not launched at very high speeds where air resistance, for instance, needs to be taken into account. Okay? Now, this is the path of a typical projectile motion problem. Okay? We're going to be launching across the ground, and we launch the projectile with an initial velocity vi, and it is launched with an angle theta with respect to the ground. Now, the reason we went through all of the vector components and breaking a vector up into its constituent components in the last couple of videos is for this particular problem right here. We will do it again when we get to forces, but for now, this is how we're going to apply what we've learned in the last couple videos. If I launch a projectile at this direction with this angle at this velocity, what I can do is break this velocity vector into its two components. Its component along the x direction and its component along the y direction. Now, I haven't explicitly stated this here, but I'm assuming that for this coordinate system, up is positive and to the right is positive. Oops. So if we assume those, right, so if I make a coordinate system here, x and y, now what we can do is break the problem up into its components problem, okay? And remember what I said, projectile motion means that the only acceleration is gravity. So what this means is if I look at the x direction, it experiences no acceleration. So the only equation that I need to worry about is going to be this equation right here. Now, this is actually a slightly modified equation. If I want to calculate what the x position is of my projectile at any given point, all I have to do is figure out at what time I want to take my point to be, and I just multiply my velocity by that time, and that will give me the x coordinate along the path, okay? Now, what I had up there before, delta x max, this is what we call the range. So if I want to find the total range, in other words, if I know where it's launched and I know with what velocity it's launched with and I know what angle it's launched with, where will it land, this delta x max is often called the range. And that's just going to be the velocity along the x direction that it's launched with times the total time of flight. And that's what t sub t means, okay? The total time of flight. Now in the y direction, okay, the acceleration is constant. It is only g. So now we have the three kinematic equations available to us to figure out what the y position is at any given time, or what the y velocity is at any given time. Now here's the key of projectile motion. Notice that this component along the y velocity vector is nothing more than launching an object upward with this velocity viy, right? So fundamentally there's no difference between launching an object at an angle and letting it travel some distance downrange versus just tossing it up with this velocity where vi and viy are going to be related by a trig function. So the time of flight and the maximum height that it achieves and so on and so forth are simply going to be able to be calculated the way we have before, but instead of using the initial velocity as the launch velocity in the upward direction, we're now going to use viy as the velocity in the upward direction, okay? But other than that, these equations are going to hold. Now there's a few very peculiar questions that we can ask with this particular situation. And this is assuming that I'm given vi and theta, okay? If I'm given vi and theta, there are three fundamental questions I can ask. And those are, what is the total time of flight? How can I calculate the total time of flight? How high does my projectile reach? What is delta y max? And finally, what is the range? Okay, what is delta x max? I want to know what those three quantities are. And I can calculate them for any given VI and any given theta under the assumption that air resistance is negligible. That's what we will do in the next video.